But the situation and its consequences are more complex than simply warmer weather, and we'll discuss this. It's important to be clear right up front that the science on the main points surrounding climate change really is settled. It's not a question of belief. The essential facts of climate science have been in place for decades now. And in 2016, the Bulletin of Science, Technology, and Society reported that the consensus on AGW, which is anthropogenic global warming, among publishing scientists is verging on unanimity. Now, like any science, knowledge is still growing, but the remaining questions about the science of climate change are not whether or not it is real, happening now, serious, important, or urgent. Globally, 19 of the 20 hottest years ever measured have been since 2001, and the other one was 1998. The 5 hottest years of all have been the last 5 years, with 2020 tying with 2016. Surface temperatures have risen significantly globally. But how can this be true when we can walk outdoors and on some days our senses tell us it's cooler than we expected? Well, it's a matter of likelihoods. Every day, the temperature is either average, cooler than average, or warmer than average. What has happened is that compared to weather records in the past, we do still have cooler than average days, just fewer of them. And we have more days that are warmer than average and more days that are hot. So these next few images will illustrate this. Now this one shows the global summer temperature distribution during the 3 decades, 1951 to 1980. And you can see a nice bell-shaped normal distribution curve, and this serves as the baseline. Here we see the temperature distribution in the 1980s compared to the baseline set in the preceding 3 decades. And as you can see, the bell-shaped curve is still there, it's just shifted over to the right. And we're starting to see occasional extremely hot days. This shows the temperature distribution for the 1990s compared to the same baseline. You can see that the curve continues to shift further to the right. And in the first decade of this century, we see the curve shifting even further to the right, with more warmer than average days now than previously average days, and extremely hot days becoming increasingly common. Although we do still see cooler than average days. And this is why occasional cooler than expected weather doesn't disprove the science of climate change. So why is this happening? As you probably know, it's caused by the accumulation of greenhouse gases in our atmosphere. And while carbon dioxide, or CO2, is certainly not the only culprit, it is a major player. CO2 is now commonly referred to as just carbon, although chemically, what we're talking about is not the element carbon, but rather the compound carbon dioxide. Now we know that much of the heat energy in the atmosphere comes from solar radiation and warms us, which is a good thing. Some of the energy reflects off the surface of the Earth back into space, and the Earth itself produces infrared heat energy. And some of that reflected and produced heat energy is trapped by gases in the atmosphere that are partially opaque to infrared, forming a cozy blanket. Now, if we increase the amount of these infrared blocking components or greenhouse gases in the atmosphere by, for example, emitting CO2 faster than it's absorbed by natural processes like plant growth, then we have a thicker blanket. And we'll have more trapping of heat energy within the atmosphere. And it goes from a good thing with an ideal temperature to a bad thing, where we're seeing a net increase of energy in the system. And that is what's happening now. 30-odd years ago, I took an oath to use my scientific knowledge and skills for the protection of animal health and welfare, the prevention and relief of animal suffering, and the promotion of public health. Climate change clearly poses a threat to animal health and welfare, as well as to public health, and it causes animal suffering. So I feel I'm duty-bound to act on climate change. Climate change impacts on animals in multiple ways. There's an obvious risk of suffering to wild animals whose habitat is changing faster or farther than the species can adjust with it, or that is exposed to flood or fire. There's also a risk of overt suffering to both pet domestic animals and production animals in heat waves, floods, and fires. It's estimated that 3 billion wild vertebrates were killed or displaced, plus another 60 to 100,000 sheep and cattle killed in Australia's bushfires 2 years ago. There are also less dramatic, but also very important threats to animal health and welfare, and these overlap with threats to public health. For the most part, these center on infectious diseases and food production. Lastly, events such as severe storms, floods, and bushfires cause severe economic losses. A healthy and well-maintained domestic animal population depends on an economically stable society. If financial stresses drive families to cut costs, that may include the cost of caring for their animals. There is no place, home, or habitat anywhere in the world where animals are not vulnerable to the effects of climate change. We'll spend just a few minutes looking at how these events that impact on animals occur. Now, climate change is not a cause of drought, flood, or fire per se. Weather would still happen. What climate change does is it sets the background conditions such that the severity of all types of weather events is increased. So we'll be seeing more severe events more often. Extreme precipitation events have produced more rain and become more common since the 1950s in many regions around the world, leading to these apocalyptic-looking storms, colloquially known as rain bombs or supercell storms, becoming more common. A supercell storm hit Coffs Harbour last week. So when we're seeing extreme precipitation and flooding, that's a major risk, clearly, to animals. And we saw losses of 500,000 cattle in the Queensland floods in 2019. Now, sometimes people wonder how global warming can be blamed for causing more precipitation and flooding, and at the same time, more drought. Well, the extra heat that's being trapped actually leads to both. And as the climate changes, precipitation patterns also change, leaving some places with less rainfall than before, and long-established, relatively predictable annual patterns starting to deteriorate and becoming less predictable. Now, as hard as it is at first to imagine that drought and floods could be caused by the same problem, it's even harder initially to make the leap from flood to fire. But actually, we know that when fires occur, their severity depends on the preceding weather conditions. So when we have hotter, drier conditions, fires that occur will be more severe and harder to control. This is a screenshot from my fires near me about 2 years ago. That's me there. And this was my backyard on that day and afterwards. Now, climate change is a major threat to health as well. Infectious diseases, heat stress, air pollution, waterborne diseases, food security, and more are all influenced by a changing climate. We tend to think of heat as a discomfort rather than a killer, but that's not really accurate. And in fact, more people died from heat in the weeks leading up to the Black Saturday bushfires than died in the fires themselves. Warmer temperatures also have an impact on the spread of infectious diseases. The potential range for many diseases expands as regions farther and farther poleward get warmer. So let's talk solutions. As I said earlier, CO2 is a major greenhouse gas, but it's not the only one, and others include methane and water vapor. So in that case, why all the fuss about CO2? Well, the reasons are that it contributes a major proportion to warming. It's the main greenhouse gas that's produced by human activity, and also because it's the greenhouse gas most likely to be controllable with reasonable regulations and laws. And while there are other sources of CO2 emissions, the biggest by far is the production and burning of fossil fuels. Here are the fossil fuel emissions by source in Australia in 2018, and most other countries are fairly similar. Transport, electricity, and industry together make up the great majority. Now we know where the problem is coming from, we can begin to address it very specifically. One of the many organizations working in this area, this organization happens to be called drawdown.org, released a report last year finding that we already have the technology to reach negative emissions by the 2040s and identifying 80 areas where we can reduce and even reverse emissions using currently existing technology. The top 5 areas identified were energy, especially wind and solar, food, especially agriculture and preventing waste, industrial chemicals and materials, boring old efficiency, and transportation. The lesson they would like us to take away is that we don't have to, and we can't afford to wait for new technology to come along. We need to do what we can with what we have. So we definitely can meet this challenge. The solutions are at hand. We only need to implement them. And this includes in shelters, the places where we care for animals who are too often on the receiving end of climate impacts. Going into the next sessions of today's presentation will take you into this. So thank you so much for your attention to this little introduction, and I'll hand it over.
Thank you so much, Angela. It's really valuable to get that fundamental understanding of the issues that we're talking about, and to get a grounding in what's really at stake and why effective action is so important. Our next speaker is architect Bruce Playle, coming to us all the way from California, and he's got over 40 years of experience serving public and animal shelter clients, and he was actually an early collaborator with the UC Davis Correct Shelter Medicine program. He's brought many innovations to the animal shelter world and provides zero net energy consulting to the state of California. Presently, Bruce is working on the design of resilient earthquake and fire-resistant shelters, which also use much less energy and water to operate. Bruce, it's an absolute pleasure to have your company today.
Well, thank you for having me and inviting me, Simone. This is a great group, and I'm looking forward to sharing what I have with you, and then we can have some discussion. Let's get this show on the road, so to speak, here. About it, what this is all about, and this is a shot of our office in Davis, California. So we're going to cover three things today: is the resilient shelter, bioregional design, which is an approach towards resiliency, and because all that stuff gets hard to do at some point, things we can do now, particularly in existing animal shelters. Climate change continues to accelerate, as Angela pointed out. There's a lot to it. It's a complex topic, but we can be sure that extreme weather, flood and drought and so forth, and the fire that goes with it, and the smoke that goes with it, will continue to increase in intensity for the near future, and we must be prepared. So it's our shared responsibility to help keep the world below the 1.5 degrees Celsius. Resiliency can perhaps be most readily defined as the capacity to adapt to changing conditions while maintaining or regaining functionality and vitality during stress or disturbance. And it's directly related to carbon neutrality. And as I hope to show you today, it's a pathway also, maybe even as important as those are, in creating beautiful places in which to live and work. So the resilient shelter, animal shelters do many wonderful things, usually with the least amount of resources and making jobs difficult. But if that weren't bad enough, you have the role of emergency support during these disasters that are increasing. So coordination with first responders, emergency animal care, housing for animal victims, and then right when the emergency responders are trying to negotiate the freeways and the highways with their vehicles, the public is out looking for their pets. So there's a role played right there. Resiliency, we look at it in three main elements, and we'll only go into really the first one today a bit, but first is to determine the threats present. And that may seem obvious, but you have to go through these steps, I think, for each location to determine what the threats are, identify the risk to the operations, and then incorporate design mitigation measures. That's what we do. This is the Pacific plate that we share edges of here in California and in Australia. We have the unfortunate situation here that we're located at a plate boundary between the North American plate and the Pacific, which creates quite a bit of problems with earthquakes. Australia, you guys are lucky. You're sitting on the middle of a plate and you're just riding it with Saudi Arabia and India with not too much to do as far as earthquake goes. New Zealand wasn't quite as lucky. They got a plate boundary. That's not to say that earthquakes don't occur. As you're probably familiar, in Australia, there was one in '88, which was a magnitude 6.3. So that's a quake size that can cause quite a bit of damages. And then, of course, the wildland fire threat, which I don't need to emphasize to you. And guess what? We have the same problems here in California, partly because we share similar climate zones with drought and fire. And this fire was just put out by a large flood rain that we had today for the first time in 2 years in our landscape, but that's now causing other problems. Here's a New South Wales example of flooding. And then just yesterday in the news, because of this river of floodwater that we had coming at us from the tropics, all the fire scar areas the burn scars have been eroded, and now it's creating even further disaster. I thought this is just an interesting diagram. It's a reminder that hurricanes and cyclones don't occur at the equator generally because of the spin of the earth. So they occur in the low latitudes north and south from the equator, which hits you and it hits us and also the Eastern Pacific. You do have this resource. Some of you may have investigated the Australia Institute for Disaster Resilience and the National Recovery and Resilience Agency. And they have a whole shopping list of disasters you can look into and see when they occurred, what they were, bushfires, floods, earthquakes, etc. So carbon neutrality, I think the simplest definition is that it is a state of net zero carbon dioxide emissions. And for our purposes here, what I wanted to focus on today, as I think it relates most to animal shelters, is reducing energy consumption and water consumption. In fact, the resilient shelter should be net positive energy and extremely ultra low water use. And I think shelters are actually in an ideal position, partly because they've been neglected so long as facilities, that we can show those other guys and we can make the right moves because we're thoughtful people, and we can show leadership by example to other parts of society for a change. How about that? Bioregional design. So this is the easiest way to get there, and we've been practicing this design technique for many years. And in the simplest view of it is designing with nature. And if you do that successfully, instead of fighting nature, working with it, you can create high performance buildings, and again, which are better places in which people love to live and work. There's 3 elements to that I'm going to touch on today: climate, ecology, and culture. As far as the climate zones go, basically designing for the specifics of climate is the most powerful way to reduce energy consumption. And here's a comparative maps. I did this just for fun. California and Australia. We have desert, we have coastal regions. We don't have tropical, we do have alpine. Other than that, there's some big broad swatches of both areas that are kind of desert basically, or maybe looking at it more favorably is they're dry climates with some winter rains and they're prone to drought. So in designing around a climate zone, one has to look at the data. This is a chart that shows annual precipitation by month in the blue bars, and then the red line is the maximum average temperature per day in each month, and the blue line is the average lows per month. There's also sun, solar access, precipitation, other factors that are important. Even wind plays a role in the design of buildings, and animal shelters are no exception. To protect, where do you want to protect outdoor spaces from wind? Where do we want to put window placement? Where do we want to have indoor spaces that are open to natural ventilation? In history, people designed things more in concert with nature. We didn't know how to do anything differently. And we naturally integrated our work with nature, human rhythms, community development, and structure. And there weren't so many manufactured materials coming in from afar. And traditional buildings and the way of life were more in harmony with nature. They used a ton less energy and water and carbon. And maybe interestingly, there were no hidden impacts on the environment that we acquired when we started importing all the manufactured goods and constructing them on one site from all around the country, all around the world. And each bioregion or climate zone is unique and should be dealt with in that way. You know, a simple way again to put it is it's kind of a back to nature approach where we embrace the aesthetics of the land that we live in. So culture is the third piece, and this is sort of abbreviated deal we're doing today, but I just wanted to use our own office. When we had the need for new digs, we found that this Dairy Queen, which was a beloved community icon in the US, I don't know if there's any in Australia. You know who owns Dairy Queen? Is Warren Buffett bought that. He's one of the world's richest men, so I don't know. But this one was for sale, and we were determined to make it a pilot project for bioregional design. And by the way, reusing existing buildings is all the rage. So if you have existing buildings and you want to fix them up, you're doing the right thing. And you can, typically a full remodel will use less than 50% of the carbon compared to building new. Let's see, so I'm just going to shift this over here. So we had goals for carbon neutrality, which were to build, and the kind of the pilot project was to build this project at net positive energy at no additional cost compared to standard construction. We disconnected our gas from the building, which is a high carbon fuel, and we went all electric. We reduced heating and cooling loads in the building, harvesting on-site energy and storing it in the building, and we offset our measly energy use with the least possible amount of photovoltaics. And we did this using passive design measures. For some reason, there we go. Those included window shading, daylighting, super insulation, thermal mass, natural ventilation, nighttime flushing, and local energy harvest. Also, California, the inland area of California is populated with rice farms, and a lot of the rice is sold to Asia, short grain rice. And so resulting those, a lot of rice straw, which is basically an agricultural waste product, and it's baled here in the US as shown on the right, or for building or fodder use. And then on the left, you can see it has in the past been burned to get it out of the field. You got to get the rice straw out of the field so that there's no bacteria and you're clear for the future, the next crop. But those bales make for super insulation, and they give a very high insulation value. And that chart I showed you earlier, where there's a great difference up to 20 degrees Celsius between the average daytime high and the average daytime low during our summer months, is a tremendous energy resource that mostly gets wasted. And I imagine there's plenty of areas in Australia where you have a similar resource which could be harnessed. The way we did it here was using natural ventilation, and the same windows that open at night when the temperature is right in our summer presents ventilation of the building and also provides our carbon dioxide demand release inside the building for ventilation air. Then when that air passes across these water-filled thermal storage columns, all you have to do is knock water down a degree or two, and because it has the highest heat capacity of any material known to mankind, basically, other than some exotic metals, you have created a tremendous energy resource that's now trapped in your building. In other words, in the summer, you've trapped coolth in the building that can then accept a lot of heat gain from the occupants for the next day. And one reason I'm showing you this too is because water is such a high heat capacity material compared to air, basically we've been heating and cooling buildings the wrong way for 80 years using air-based systems. And of course, there's reasons why we've done that, but this is extremely more efficient when you use a little bit of energy to move water around. And for animal shelters, the point to make is that it puts the heating and cooling in your building right where the animals are. And because animal shelters have a high ventilation demand to prevent disease, you lose less of your heat and cool that's in the floor when you're moving air through the building, as opposed to, you can imagine if you were using the air to both heat and cool the building. Window shading is important to keep direct solar heat gain out of the building when you don't want it in there, because that's a lot of heat. As Angela pointed out in that Earth view of the sunlight coming into the planet, it's a very powerful heat source. You want to keep it out of your windows. Tubular Skylight technology has come to the point where you can take an existing building and pop these babies in it and bring natural light deeply to the interior of a building. Skylights are depending on how you use them, 3 to 10 times more efficient at bringing daylight into a building than are windows. I mean, you still want windows, right? But if you want natural light in the building and it's a broader footprint, this is the way to do it. So here's a result: net positive energy at no added cost. We produce more energy than we use. Right now, we're charging 2 electrical vehicles off the building, and it has one of the lowest energy utilization intensity figures in the United States. Here's a few shots on the inside, detailing. You can see if you just use genuine materials and avoid the manufactured stuff, it's like, it's the difference between, I don't know, eating broccoli and eating candy, maybe. That's not a fair comparison, but you can see the effect when you're no longer trying to fight the system and you're working with nature. You have outdoor spaces that can be freely utilized. We have a few items like this: solar powered fountain, edible landscaping. So where is this newest and most resilient animal shelter? Well, sorry, there's not one yet. That's what we're working on, and I'll keep you posted. We are doing elements of it though, and we'd like to highlight for you today the kind of improvements that we think any existing shelter can do to both improve animal care and to combat climate change. So I'm thinking there's the top 5 ways to improve animal care. So number 5 on the list would be to implement low-cost noise mitigation in an animal shelter. There's quite a bit of low-hanging fruit, as they say, in that regard. One of them is caging, and the latches on them are an exceptionally frequent and abusive sound to animals. The companies now have come up with silent latch designs, but maybe you don't have those yet. There's retrofits you can put on them, as shown on the right. And Dr. Wagner is experimenting right now with putting heat shrink tubing on existing latch components, which makes them silent. And again, that's something, once it's worked out, that'll be a real boon. It's sort of a do-it-yourself thing. 4 on the list of what to do to improve an animal shelter existing, and these are mainly facility things, I should say, would be to try to add variety to housing in things like catios, group rooms, to provide flexible, non-caged spaces for enrichment and socialization of animals. How can that be done? Sometimes it's just an add-on. A catio can be an add-on, and other times we work with shelters to carefully identify walls that can be moved or rooms that can be joined together, or sometimes there's underutilized rooms in a shelter. It never worked out like it was planned to be, and there's a room that just isn't working. That's one thing. Similarly, or number 3 on the list, we're working up towards number 1, is establish the separate isolation housing. And again, this is a matter of planning with the careful modification of doors, walls, and so forth. We find that we're often able to provide quarantine and isolation spaces, which are so critical to help prevent disease transmission in a shelter. Number 2, retrofit housing to double compartment. I'm sure you're all well familiar with the benefits of that. There's less animal stress, easier to maintain, and there are more hygienic conditions. All of those directly improve animal health and their adaptability. Number 1, so here it is: implement capacity of care principles, reduce length of stay. So that's a gold standard in the, finding the right outcome for every animal, increasing the throughput in a shelter, and reducing the length of stay. All those things are important. And of course, this is a focus of the UC Davis Correct Shelter Program. If you haven't been to their website, you can go there and see a lot more about that. So now on to what things we can do today to combat climate change. So number 10 on the list would be to use low flow fixtures, drought resistant planting, and drip irrigation. And you know, there's a couple ways to do this. One is you just go through and replace all the fixtures in your shelter. I mean, actually, you may not have that many fixtures in your shelter, which makes it slightly easier to replace them. Or as the fixtures become worn out or need replacement, then you can have a program to put in ultra low water use fixtures. And it's the valve as well as the fixture itself. They work in combination. And then you can work towards native planting and drip irrigation. And that's if you have any planting at all after this many years of drought and it hasn't burned. Number 9 on the list, wash with cold water only, then use the dryer heat to kill germs. You know, the main animal shelters use a tremendous amount of water and energy washing towels and blankets. And so the goal is you want to get those clean, but you're also trying to kill bacteria that might be harbored on them. You don't have to kill them twice. The dryer is going to kill them at 150 degrees Fahrenheit or 66 Celsius. So you don't have to use hot water in the washing machine. In fact, if you don't want your staff to use it, the best thing is just disconnect the hot water from your washing machine, because people love to run hot water and everything. I don't know why. So that saves the energy to heat the water, and you're still killing the bacteria. So number 8 on the list is even better, get yourself a solar powered dryer, commonly known in the vernacular of things as a clothesline. So here's some clothesline solutions. The one on the right, you know, the Amish are really a sect that's populated some parts of the US, mostly in eastern Pennsylvania, as it turns out. They're of a German extraction. Oops, I'm sorry. And their belief system is not to use mechanized things. They ride horse and buggies. Some of you may be familiar. And so they don't have washers and dryers, and they have developed a clothesline technology that's superior to most. You can buy their pulleys and cords and so forth on the internet. They're very entrepreneurial as well, turns out. But if you're not into that, these things could be radiated from a laundry on an existing shelter. There's also the umbrella style. And on the left, again, is your do it yourself style. Item number 7, divert gray water from laundry to yard landscaping. This is kind of another do it yourself concept. The codes in North America and Australia permit, without permitting, the diversion of water from your washing machine and other non-black water sources into landscaping. You bury a perforated pipe shallow in the ground, and you can water your yard with all that laundry water that's coming out of the shelter. Number 6, spot clean kennels, deep clean only for new occupants. So the idea is, oh yeah, and I got it, Simone, this is what I told you when we first talked about this. You got to go to your Chinatown and go to your Asian food market where all the vegetables are kept dry. And because water is the one thing of 3 that bacteria needs to survive and thrive. So as soon as you wet down all those vegetables, and I don't know if they have these in Australia, but they have these rainwater sprinkle systems in groceries here to make the vegetables look fresh and so forth. The grocers love it because the vegetables, when people take them home, they only last a couple days. Whereas if you just kept them cool and dry, they will last more than a week. So it's a simple fundamental thing. Don't give bacteria water to thrive with. So basically for animal shelters is you want to keep the shelter dry. You want to clean up the so-called accidents. There's different spot cleaning products coming to market that do this. This is an attachment for a pressure washer that's being made by Ryobi. And then once that animal occupant is out and a new one comes in, that's when to do the deep cleaning. And that results in cleaner kennels because you're not using so much water and it saves water. Number 5 on the list, improve building ventilation. This is especially poignant given the complete COVID disaster that we're all still trying to emerge from. But basically, if you have operable windows, operate them. If you don't, you can retrofit windows into operable ones. Fans, ceiling fans with air movement, they expand the thermal comfort range in buildings, and you can actually turn your thermostat up or down a little bit, saving energy just by the fact that air is moving in a space. People don't like dead air in a room. In fact, some of these now, not wanting to waste a capitalistic moment, they've put UV features on the top of the fans too. I'm not sure how effective those are, but that's what they're doing. And then check minimum outside air settings for any mechanical systems you have. So your outside air ratio is enough, but not too much. Number 4 on the list were the top 10 ways to combat climate change. Go all electric. Get off gas, start a reduced carbon diet. And Australia, as you know, is a wonderful wind and solar resource. When it's fully tapped, will create a renewable electricity market. Meanwhile, any things that you have that fail, and they do over time, you can replace a heat pump. You can use electric water heaters, electric clothes dryers, etc. Number 3 on the list, we're getting close to number 1. Everybody getting excited? Is add daylighting. Daylighting's great. People love it. And I haven't a way for them to tell me, but I think animals love it too. And there's probably not been a whole lot of study done on that, scientific study, but it's some of this stuff ain't rocket science either. You want to bring what's good for people of this type is going to be good for animals as well. And so you can see in the picture in the middle, there's an LED light fixture overhead, and then those 2 rectangular or square panels that are lit. Those are the diffuser lenses for tubular skylights. And this is an unretouched picture. So between that and the 2 clear story windows, there's an abundance of natural light in this space. We always put it over the animals before we give it to the people. Number 2, convert to electric vehicles and add charging and maybe ultimately batteries. There soon will be a fleet of electric service vehicles for animal control and other functions. And number 1, this sort of maybe is a, not the most obvious or is the most obvious, is just add photovoltaics to your facility, either on carport canopies or on the roof of your building. Now that's an initial investment if you want to own them, that'll have a payback period to it. But there's also power purchase agreement outfits in Australia that are putting these in. It's not quite as good an economic deal, but you can get it long term, but you can get the photovoltaics in a lot sooner and benefit from them. So, there's a lot of work to do in closing here. And we are doing a study just now, starting with UC Davis, to look at reducing the carbon footprint of animal shelters. And we're interested in having other shelters input to that, and maybe shelter data for water and energy use. If you're interested in that, you can email me at bplayle@indigoarch.com, and we'll get you plugged into that process. So that's it. I want to thank you very much, and I'll open it for discussion, or back to you, Simone.
Bruce, that was fantastic. That's I love me any sort of countdown list. So you've met met and exceeded all my expectations there. It was wonderful. And what I particularly love was to paraphrase you, was saying that shelters can live lightly on the earth and provide leadership by example. I think that right there really encapsulated everything about your presentation. So I'm sure people will have questions for you, Bruce, but before we go to those questions, we've got our last presentation for today, which actually comes from the Vets for Climate Action ClimateSmart team. And ClimateSmart is a new initiative designed to really equip clinics with the skills and the knowledge that they'll need to be more sustainable and more climate active. And presenting today will be Jeremy Watson, but Corinna, I just also wondered if you could just give a wave there as well. So Corinna Klupik is the brand new project manager for this ClimateSmart program. So she is always interested in hearing from people and ready and willing to help with advice and recommendations. So Jeremy, I shall hand over to you.
Okay, well, thank you very much, and thank you, Angela and Bruce, for those great presentations. Look, I'm here in my role today as really a volunteer for the Vets for Climate Action, and I've been working on the ClimateSmart program for over a year, and we're very excited to have Corinna on board to help lead the program into its next phase. So I might just start by sharing my screen if I can. And got that? Okay, so the purpose of my presentation today is to highlight the benefits of a sustainable culture within your practice and to show how this can be achieved with the Vets for Climate Action ClimateSmart program. So once Bruce has designed your sustainable premises, then you need to build a lasting team culture of sustainability to maximise its potential. So what is sustainability? And so the UN defines sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. And so what does the UN definition mean in practical terms? It's about building a team culture that minimises waste, reduces the carbon footprint of your practice, and cares for the environment. And so there are many components to sustainability. It's good to have an overall plan. And there is a huge amount of information available now about improving the sustainability of your business. And it can be overwhelming trying to decide where to start. So the Vets for Climate Action ClimateSmart program makes it easy for you. It's designed to be a comprehensive sustainability implementation program that is uniquely tailored to the veterinary industry. And so there are multiple benefits to the ClimateSmart program in addition to its environmental credentials. For example, engaging the team. Practices are always looking for ways to energise team culture. For example, we have fear-free clinics, we've got cat-friendly clinics, and hospitals of excellence, all designed to motivate the team and provide better care. This sustainability program delivers all of this and more. Increased profitability is always attractive to business owners. Rapid technological advances mean that changing to more sustainable practices makes money and our job easier. So it's a win for management and for the team. And as practicing vets, we have an enormous reach into the broader community. We are a caring profession and we are guardians of animal health. So we can provide leadership, educating animal owners in the connection between animal health and climate health. To solve the climate crisis, it will require a whole of community effort. You get increased loyalty. So more than 60% of the population now wants action on climate change. If your clinic is demonstrating their commitment to climate action, you will gain majority support from your client base. And of course, helping to fight climate change. So to truly achieve a net zero by 2050, it's going to take a whole of community effort, and the veterinary profession has to play its part. What are the key features of the ClimateSmart program? Well, the ClimateSmart program utilises and recognises a process of cultural change management in a business setting. First, we address the why. Why do we need to change? What is the problem we are trying to solve? Then we generate some interest. These problems can be solved. Other people are doing it, so you can do it now. We create a desire to be sustainable. There are rewards for undertaking a sustainability program. So you get praise from clients, you save money, reducing your carbon footprint and making a positive contribution to animal health. We demonstrate a new sustainability space and then create a desire within your team to go there. With desire, you need action. You need an action plan that is clear and well-resourced. Success is measurable and celebrated, and the program includes follow-up to ensure an enduring culture of sustainability and continuing to take advantage of the rapid developments in this area. The practice champion leads the program. They receive leadership training. Sorry, I just moved back there. The practice champion leads the program. They receive leadership training and resources to engage and guide team in a busy practice. So we have 6 modules covering all areas of sustainability, with each module taking 4 to 6 weeks to complete. Baseline data is collected and used to measure progress. You can also benchmark against similar practices. There are significant cost savings resulting in increased profitability, and by engaging the whole team, the benefits of action on climate change will radiating to your visiting clients. So you can see here, the program consists of 6 modules. And so for the sake of brevity, I'm not going to go into the details of all of the modules, of all the components of the modules, but I will just give you a few key examples from each one. So the first module is about recycling and reducing landfill. A waste audit is a great way to engage the team and make people own their waste. A key activity of this module is for the team to conduct a waste audit to analyse what can be recycled in practice. It costs 6 times more to put paper products in a commingled recycling, or 28 times more if they go to landfill, compared to a paper cardboard recycling dumpster. And the challenge for our team here is to reduce the need for at least one of our weekly landfill bills, which will save us $2,300 a year. And so we've decided that half the saving will go to cocktails for our mid-year function. Everyone will win. Significant savings can be achieved by ensuring all paper and cardboard products finish up in the dumpster bin. And so just back to what Bruce is saying about the design, you need to have a practice that can accommodate the space to put a dumpster bin to then take advantage of the savings it offers. And our second module is water, again, touching on some of the things that Bruce talked about. Changing tap aerators, for example, can be done by anyone and can halve the amount of water flowing through your hand basins. Turning off the scrub sink taps while you're scrubbing can save at least 5 litres of water per wash. And ideally, fitting in a foot pedal can mean it's just turned on and off as needed. And as Bruce mentioned, a rainwater tank can harvest water for use in the toilets and can also be used in the garden as well. The third component of our modules is about energy efficiency. And as Bruce said, the future is all electric. Heat pump technology used for hot water and central heating is more energy efficient, cheaper and cleaner than gas. Eliminating gas use will reduce your Scope 1 emissions as part of your carbon audit. You can also save on your building costs by not having to connect to gas. The ClimateSmart program will guide you through a good energy audit, which is an important part of working towards a full carbon audit and moving to a carbon neutral business. And you can see here, we've just upgraded to an electric clothes dryer from our old decommissioned gas dryer right there. And also, as Bruce mentioned, ceiling fans are a great low-cost option to maintain comfort and reduce load on air conditioners. So the fourth module of the program is about procurement. The procurement module trains the team to analyse and evaluate clinic purchases to select the most sustainable options. They can also lobby suppliers to provide more sustainable alternatives. You can see, for example, here we use office paper. Recycled paper is good for sustainability, but may not have a lower carbon footprint than non-recycled. Choosing carbon neutral recycled paper is a much better option. But the best option of all is to stop using paper altogether and communicate by electronic means. And good procurement also means great coffee, and this is a win for your team. Freshly ground and brewed coffee is cheaper than pods, and the waste is fully compostable. Another benefit is a more productive team, as there's no need to do a coffee run down the street. We now make better coffee in-house. The fifth module is about renewable energy. Rooftop solar is an established way to reduce your power bills and reduce your carbon footprint. In our clinic, the large portico at the front of the building here faces north and allows us to add another 24 panels, giving us a total of 115 panels. So in 1 year, we produce nearly as much energy as we consume and save thousands of dollars. EVs. An EV charge will become widespread in most workplaces, again, as Bruce has mentioned. This way you can make use of the battery in your car to soak up the extra solar power in the daytime. With our current feed-in tariff of 6 cents a kilowatt hour, you can fill up your car for $5. And as you progress through the ClimateSmart program, you'll gain the information, skills, and understanding to proceed to registration as a carbon neutral business and make a genuine impact on reducing climate change. And lastly, the sixth module is about chemicals, toxins, and pharmaceuticals. And in particular, I'd like to highlight here the impact of isofluorine anesthetic gas, which is a potent greenhouse gas, and it's approximately 6,000 times more potent than carbon dioxide. The discharge of anesthetic gas contributes about 7% of carbon emissions in my practice. So simply turning down excessive flow rates is an immediate start that can provide benefits. So in summary, the VfCA Climate Action ClimateSmart program is a great way to engage your team in a culture of sustainability. Sustainability is a rapidly evolving opportunity for veterinary practices, and we need to be open-minded and supportive as we play our part in addressing the challenges of climate change. Thank you, and that concludes my presentation.
Jeremy, thank you so much. It's clear from your presentation that there are really so many relatively straightforward and practical things that can be done to help improve the sustainability of a practice or of a shelter. And I think it's easy to be overwhelmed by that concept, but it's great to see that the ClimateSmart program breaks that down into really achievable steps. So thank you so much. Now, before we move on to some questions, one thing we always do at these VfCA webinars is take a group photo, a screenshot. So if you're comfortable to do it, it would be wonderful if you could turn your camera on and smile, and we'll take a quick screenshot of the group. So I'll give everyone a couple of minutes to do that. It's also a good opportunity. I like to check out everybody's backgrounds and where they're coming in from, imagining if their background is real or Jeremy, I'm suspicious yours isn't, but I could be wrong. Maybe your grass grows very well. There we go. So Al, have you got that screenshot there?
Maybe we'll just do a 3, 2, 1. Everyone give a wave or a thumbs up or a smile.
All right, you give the word, Al.
Okay. 3, 2, 1. Ah, that's lovely. Thanks, everyone. Back over to you, Simone.
Thanks, Al. So, points for discussion. Does anyone have any particular burning questions that they'd like to ask any of our presenters? I know that someone was asking for your email, Bruce, for you, because you're studying into carbon use or within shelters. So I wonder if you would mind popping that into the chat, or I can. If you, it was, let me see if I remember. Playle at indigoarch.com. Am I right?
That's it. Yeah.
Oh, well done.
Chat.
Let me put that in, and then everybody's got that if they did want to contact you about any of your innovations or that research. I think we've got a bit of a shy group today, so keeping an eye. And feel free, if you prefer not to use the chat, just turn on your mic and you can ask a question as well. It looks like Jeremy's got a question. Yes, Jeremy. Oh, you're on mute at the moment.
Sorry, I just had a question to Bruce about heat recovery, ventilation, and in a retrofit situation. And I've had a discussion with some vets who design, some architects who design vet clinics about retrofitting heat recovery ventilation to kind of get rid of what we call the vet clinic smell. So maybe could you have any comment on that?
Yeah, heat recovery, basically that's a system where as the outgoing air is leaving the building, there's a transfer wheel and it transfers heat energy to the incoming air. And so I would say and they can be sort of problematic and maintenance issues and so forth. And you can get some residual smell from one side to the other, depending on the type of heat transfer used. I think it depends on the climate that you're in. If you're in a very temperate climate, And you can, and especially if you did have a hydronic system where you can afford to have some air moving out because it may not be fully conditioned, but the room is comfortable because of the hydronic slab, then you may not need a heat recovery wheel. It's probably better without it just from the maintenance aspects. But if you're in a very cold climate or an extremely hot one where you're going to lose a lot of your conditioned air, then yeah, I would recommend a heat recovery wheel.
Bruce, I was fascinated by those. Are they heat sink columns that you have in your building? I thought they were structurally so appealing, and to think that they serve such a purposeful role within the climate control within the building.
Yeah, it's one of those things, some people love them and some people don't, because they're basically they're irrigation pipe that's been sealed and used to hold water. And but yeah, we operate a lot just on fundamentals. I can't say I'm a scientist for sure, or that I have tons of data on anything really, but we work on what makes sense with the fundamentals and on best practices. So yeah, the concept is, and this works in most climates except for tropical hot humid climates, is you fully insulate your building, super insulated as much as you can, so you're able to trap heat and cool inside of the building. Then put all of your water storage inside the building, and it makes a tremendous thermal flywheel effect. So the outdoor ambient temperatures can fluctuate all day long, but the indoor temperatures very little variation. That act alone just saves a tremendous amount of energy in a building, but because typically we don't ventilate them at night when we could be capturing that outdoor energy, and we just don't do it that way. And so buildings lose that ability to even themselves out with the ambient outdoor temperature. But yeah, water tanks, there's different ways to store water, and we're sort of exploring alternatives. This is one way to do it. You don't have to use water. Water just happens to be the best. It's water is one of those, is a material that has such unique properties that makes life on Earth possible. One, we need something to drink, and two, it's the only material that, one of the few anyway, that freezes when it expands, it freezes, so it floats. I mean, all those things you know about water, but you can use masonry or concrete as well. It's a little easier to incorporate in a building. It has about 40%, I think, of the heat capacity that water does. Heat capacity is just basically the ability for a material to capture and hold heat energy. And so the more it can store it, the better off it can be used like a battery for your building.
And we've probably got time for just one more question. Corinna, I can see you've got your hand up there. Do you have something to ask or discuss?
Thanks, Simone. I'm happy for someone else to take my place, but if there's no one else waiting, I was just struck, Bruce, during your presentation about the similarities between California and Australia. You know, there were so many things that you mentioned, and I just wondered, is there any collaboration, cooperation between California and Australia on these sorts of initiatives existing already? And what is there scope for us to do more together because of our many similarities?
I think there is a lot of room to do more together because of those similarities. And I'm sure there's other collaborations going on, but not as much as there should be. So yeah, we would look forward to participating in some joint activity to figure out how to get to the bottom of doing things in a way that we can preserve our role as being responsible to the environment. I mean, if we don't all, we have a lot of clients, you know, different people, we can't always just tell them this, but it's like, look, we're nuts. We gotta, you know, you gotta start doing something. If we don't start doing something, who will? And so it's, I do think animal shelters, because of their sort of lowly status in the world of facilities and what goes on, I'm sure you have the same problems we do here with funding. They're inadequately funded. People, you know, a lot of people don't care so much about animals. But if you can basically leapfrog because you have the energy and the interest to make things better, that is a huge, that's the biggest resource that a group like this has actually, is that interest, because it can propel you and us and everybody and show the world how to do it, basically. That's my belief anyway.
Simone, do you mind if I just add, it was so lovely to see the philosophy that underpinned your entire presentation, that the care for animals was front and center, and just working with versus fighting against the environment. They're just such basic and beautiful principles. So thank you so much for incorporating that so well. Yeah.
Well, we better wrap it up there so everyone can get back to work, or in your case, Bruce, probably go and have some dinner. It's wonderful to have everyone's company today, and especially that of our presenters, Angela Frimberger, Bruce Playle and Jeremy Watson. Bruce, any final words from you before we wrap things up?
No, really, just I'm very happy to have been invited here today, and it's nice to see some compatriots out there that have the right ideas to do things. And any ways we can work together, we're more than happy to. And even to the point of doing work in Australia, there's reciprocity between the US and Australia for architectural licensure. I imagine there's maybe similar things for veterinary practice. I don't know, but anyway, it wouldn't be that hard to do things in your neck of the woods, so to speak.
And that's the sort of attitude that we love, Bruce. It's really not that hard to do things. So we'll leave it there. Thank you, everyone, for your company. If you are interested in finding out more about Vets for Climate Action, you can visit our website, and also for Getting to Zero, if that's a new concept to you as well, you can visit the Getting to Zero website and find out more also. Thank you, everybody. Do take care. We hope to see you at the next VfCA webinar. Take care.
Thank you. Bye.